This is Earth. Currently, it is safe, it is comfortable, it is home. But in exactly 10 seconds, I am going to break it. I have gathered the data from the deadliest objects in the known universe, planets that rain glass, stars that crush atoms, and black holes that eat light. We aren't just going to visit them like tourists, we are bringing them here. Welcome to the ultimate solar system stress test. We're treating our home planet like a crash test dummy to answer one simple question. How much punishment can Earth take before it cracks? Let's begin with stress test number 1, thermodynamic shock. We're going to replace our sun with Kelt 9b. This is the hottest exoplanet ever discovered. It is a gas giant 3 times the size of Jupiter, and it is burning at 4,300 degrees Celsius. That is hotter than most stars. If you were standing on Earth when this heat hit you, you wouldn't just burn. The heat is so intense that it doesn't just vaporize water, it tears molecules apart. On the side of Earth facing this monster, the very chemical bonds holding your body together would snap. You would become a cloud of atomic gas before your brain could register the pain. Scientists describe this heat as intense enough to boil diamonds, not melt them, boil them. Earth's oceans would evaporate instantly, creating a super pressurized steam atmosphere that would cook anything the radiation missed. But maybe heat is too quick. Let's try something slower. Stress test number 2, gravitational shearing. We're going to delete our moon and replace it with Saturn. Immediately, the sky is dominated by a gas giant 33 times wider than the moon. It looks majestic, but physics is about to ruin the view. Saturn is 95 times more massive than Earth. The moment it appears, Earth stops being a planet and starts being a moon, and we are falling. As we spiral closer to Saturn, we hit a mathematical wall known as the Roche limit. This is the invisible line where the gravity holding Earth together is overpowered by the gravity pulling us apart. It isn't a fair fight. The side of Earth facing Saturn gets pulled harder than the side facing away. The crust fractures. Mega tsunamis thousands of meters high scour the continents. But that is just the warm-up. Within hours, Earth is literally ripped into billions of pieces of floating space debris. We don't die from a collision, we die from the tension. Earth would spread out and turn into a thin band of rocky shards orbiting the gas giant. We would become Saturn's newest ring. If gravity and heat are too messy, let's try chemical warfare. Stress test number 3, atmospheric swap. We're stripping away our nitrogen and oxygen and injecting the atmosphere of Gliese 1132b. This used to be a Neptune-like planet until radiation stripped it down to its core, leaving behind a toxic blanket of gases. The moment this hits Earth, the sky turns a hazy brown. The first thing you notice isn't the sight though, it is the smell. This atmosphere is rich in hydrogen sulfide and methane. The entire planet now smells like a sewer filled with rotten eggs. But the smell is the least of your problems because you're also breathing hydrogen cyanide. This is a compound used in chemical warfare. 1 breath causes dizziness, 2 breaths cause vomiting, 3 breaths and your cells stop being able to use oxygen. It is a planetary gas chamber. Without ever touching the surface, this atmosphere would sterilize the Earth, leaving it a stinky, silent rock drifting through the void. Now it is time for the final boss. Stress test number 4, the cosmic needle. We're going to fire a primordial black hole through the center of the Earth, but not a big one. This black hole has the mass of Earth, but it is the size of a coin, just 2 centimeters wide. We are firing it at the speed of light. You wouldn't see it coming. It would pass through the planet in 0.04 seconds. It would be like shooting Earth with a gravitational bullet. As it pierces the crust, it doesn't just punch a hole, it drags the fabric of space-time with it. If you were standing near the impact site, you would experience spaghettification. Your body would be squeezed horizontally and stretched vertically, turning you into a long, thin noodle of biological matter. But the real destruction happens deep underground. The black hole would tunnel through the core, dragging molten iron and mantle with it, creating a shockwave that liquefies the planet from the inside out. Earthquakes would shatter every tectonic plate simultaneously. The planet wouldn't explode immediately. It would crumble inward, collapsing into the vacuum left by the bullet. So what have we learned from this autopsy? We spend a lot of time worrying about asteroids or nuclear war, but the scariest thing in the universe isn't a collision, it's gravity. In almost every simulation, we didn't need to touch the danger to die, we just had to get close. Earth is fragile not because of its crust, but because of its balance. We are in the perfect position at the perfect distance with the perfect chemistry. And luckily for us, that balance is holding for now.